Hello. Hi,
Have
everyone.
fun.
Thanks so much. I'm Arjun. I'm one of the founders of Everclear. We were formerly known as Connext, which is a name that you perhaps may have heard of before. But if not, Connext was a protocol. Oh, hey. Connext has been around in this space for a very long time. We were one of the first L2s on Ethereum, and then we also pioneered the intent-based bridging model in 2021. Everclear is kind of an evolution of what we've been working on for years. It stands at kind of in this really, really awesome time that we live in, where we are seeing this accelerating fragmentation in the space, but we're also seeing intent-based bridging starting to be adopted everywhere. And so Everclear is going to tell, or at least this presentation is going to talk a little bit about, like, contextualize this problem, why it exists, and what the source of it is. Oh, I see. Okay, that's fair. Everclear is going to, or this presentation is going to contextualize the problem a little bit better and help us understand where the sources of fragmentation come from, and then talk about how we can actually solve this. So, fragmentation. Who here has not heard about fragmentation? Cool, awesome. I gave a talk related to this a couple of years ago, and like every single hand went up. So it's really very promising and I guess concerning that every single person is dealing with this problem today. Obviously, this fragmented experience that we live in is awful, right? Needing to go and use applications that are living on multiple chains at the same time, it just doesn't really work. And this problem just seems to be getting worse, right? There are 61 layer 2 projects now live, and then another 79 in process of going live, and this is coming from L2 Beat. That's a lot of rollups. And this doesn't include a lot of like application-specific rollups. This doesn't include projects that have yet to be announced. There will be thousands of rollups eventually. That is the plan, right? That is what people have been working towards. Rollups are the new servers. So how do we actually address this? On Twitter, if you've been following the narrative, the common narrative, everybody's talking about chain abstraction. Chain abstraction is this vision, this outcome that we're heading towards, where as a user, you should never have to care what chain you're on, right? Sounds really, really nice. And chain abstraction, because it's an outcome, is something that a lot of different projects collectively are working on. So you might have seen some of the announcements coming from Near working on chain signatures, which is a way to kind of like be able to sign transactions from any chain, to be able to initiate transactions with funds from any chain. There's also been announcements coming out from projects like Particle and Socket that are trying to unify balances across chains. Announcements coming out from Across and a bunch of other protocols that are helping kind of address like how do you bridge, how do you move the underlying funds between chains. There's a whole ecosystem being built around this, and that whole ecosystem is centered around this concept called intents. This might be a term that you've heard of before. Intents, I think, tend to confuse a lot of people. So here is an example of a very simple intent protocol that we're all familiar with called Uber. Uber is an intent protocol. When you want to go from point A to point B, you go to the Uber application, you say, I want to get to this place. And Uber implicitly assumes you want to get there as fast as possible and ideally with the lowest price, right? So Uber finds you a solver, in this case a driver, someone who is going to fulfill your desire. It's kind of a genie in a bottle situation. Uber's driver gets you to where you want to go, and then you pay them, you settle with them. This whole flow makes sense, right? It makes sense. This is how marketplaces are created. And this is effectively what we want to do across chains. Any action that you want to take across chains can be abstracted away. It can be done by a service provider that has gas on the chain that you want to get to, that already has liquidity there for you. So that, for example, say you have, $100 on Arbitrum, and you want to go and deposit into Aave on Optimism, instead of having to go bridge those funds yourself, instead of having to go and switch chains in MetaMask, having to go and get gas to go and deposit into Aave, some solver, some third-party actor can go deposit into Aave for you, and then from your perspective, the whole transaction is done. And then later on, they can go and claim your funds. Now, that second piece is actually what's kind of interesting, because as it turns out, this creates some interesting dynamics. This is a flow diagram that represents who is actually solving these transactions today. When you go and you bridge on Across and DLN, who is actually fulfilling these transfers? And what you see is something very interesting, which is almost all of it is being done by a few people, right? Solvers are super centralized. And there's good reasons for this, right? The solver ecosystem really requires a level of sophistication today that just doesn't exist for most people, right? Most people are not able to run solvers because you have to be a market actor that understands not only the technology, but also understands how to move liquidity between chains. And this is the fundamental problem that we're kind of seeing, is that there's this dirty secret of chain abstraction. Chain abstraction is this whole thing where like, we're going to remove the need for anyone to have to care about what chain you're on. But the reality is, you're not removing that complexity, you're just giving it over to solvers, and now solvers are the ones who have to deal with it. And so who can deal with that complexity? Well, the sophisticated actors, right? This is a not real graph of volume versus the amount of transactions that you're filling. And like, you can see where Wintermute stands in this with the amount of liquidity that they have, hundreds of millions of dollars of capital. And you could see where you would stand in this if you were to run a solver. This is a problem, right? This is not decentralization. This is TradFi. And I don't know about you guys, but I don't see a point in rebuilding TradFi. What we want this graph to look like is more of a straight line. Ideally, it's just horizontal, but at least something that looks like this would work, right? So how do we get there? To understand why this is a problem, I think we need to just double click on what's actually happening when you're solving an intent. And so this is just the same kind of Uber flow that I talked about, the same Aave flow that I talked about, right? As a user, you want to deposit into Aave across chains. Solvers are competing against each other in order to fulfill that desire of yours. The solver fronts their own capital, but it's the third step that no one really talks about, that happens after your transaction is over, that actually determines where all of this comes from, which is the solver has to settle. They have to get repaid. And the problem is, you have given your funds on the source chain. Right? It's fine if it's optimism. What if it was degen chain? What if it was some totally random long tail L3 that nobody's ever heard of? Well, now this solver, ideally not Wintermute, ideally somebody else, but this solver now has funds on degen chain. They need to figure out how to get it out. And as it turns out, that's a really, really difficult problem. This is what we call rebalancing. Right? Solvers need to continually rebalance their capital to get it to places where it can actually be used again. Because, of course, they're businesses. They don't want to just like leave money lying around places and not be earning on it. So how do you do rebalancing? Well, as it turns out, nobody really has an answer to that. The way that you rebalance capital is through going to a bridge. And then the way that the bridge rebalances capital is going to a market maker. And then the way that the market maker rebalances capital is they go to a centralized exchange. And then when you go and you talk to centralized exchanges about it, they're like, yeah, we are hiring a team of 20 people and they're like hitting the button on the canonical Arbitrum bridge and we're taking the 7-day lockup with like hundreds of millions of dollars. Like that's actually what they do. And it's just because there's this like fragmentation issue, right? Fundamentally, there's a bottleneck in our system, which is that moving information, moving tokens between chains takes time, fundamentally, right? Minting and burning tokens between chains is going to take time. If we want it to be secure, it will have to take time. So how can we solve this? Here's a really, really interesting thing that we learned. 80% of the movement of funds between chains actually nets out, which basically means for every dollar that you're sending into a chain, in this case, let's say BNB chain, or yeah, BNB chain. In this case, 85 cents, right? So for every 85 cents, or every dollar you're sending into BNB chain, 85 cents is coming out in the same time period. So that kind of begs the question, why even send $1? Just send 15 cents, right? And the reason is because everybody doesn't really know what is being netted out. And actually, before I jump into that, here's a quick aside on what I mean by netting, because I think netting is sometimes a little bit of a loaded financial term and not everybody gets it. Netting is a process by which you can turn all of these like financial commitments that people have, in this case, $420 versus cyclical payments. This was not intentional, by the way, I promise. It was just happened to be in the diagram. And then that is actually, in practice, only $10 of delta, only $10 of final moved funds. So why do $420 worth of transactions when you actually only need to do 10? This is what netting accomplishes. And in fact, netting is a core part of all financial systems, right? What is Visa doing? Where are they actually getting their capital efficiency from? They're netting. How does the New York Stock Exchange work? They net prior to settling transactions at the end of the day. Netting is such a critical piece of how mature financial infrastructure works, but it doesn't exist in this space yet. And it doesn't exist because every single player that's in the space is playing a PvP game against one another. So to solve this, we're introducing an entirely new primitive. We're introducing clearing layers. Clearing layers are a mechanism that allow different parties in the ecosystem to be able to coordinate with each other to net off flows of funds. So instead of me having to go and rebalance funds back to Polygon, and someone else having to go and rebalance funds back to Arbitrum, we can find a coincidence of wants with each other and instead just not do anything, right? netting costs nothing. And that's the really crazy thing about it. How does it actually work in practice? This is a little out of order, my bad. How does it actually work in practice? Well, we have a system that basically acts as it's its own rollup. It acts as its own kind of state container. Everybody declares what they want to do, where they want to move their funds to this rollup, and then the rollup basically finds coincidences of wants between people. The strategy that it uses is modular. Out of the gate, we're using a Dutch auction, which you may have heard of through other projects like Gnosis. And perhaps what's most interesting about this is that this is a zero TVL system, right? It's not a system, it's not a liquidity pool, it's not a bridge, it's a mechanism to allow bridges and liquidity pools to work with each other to be able to net off their obligations. And this kind of gets into the thing that I showed a little earlier, which is historically, every approach towards solving fragmentation has been basically the same. It's been, I'm going to build a bridge that gets more liquidity than your bridge, and therefore I'm going to win. That's how we've ended up in this place, right? Each new bridge that launches is actually making fragmentation worse and not better. Our hope is that with Everclear, with a clearing layer, you can actually remove the need for this to happen, right? Rather than building another bridge, rather than building another cross-chain protocol, you can allow these cross-chain protocols to coordinate with each other to get a globally optimal outcome. And this is really the thesis of Everclear, right? Everclear sits at the bottom of this new and emerging chain abstraction stack. It's coordinating settlements between like people, liquidity actors on top. So this is intent solvers, it's market makers, it's centralized exchanges, people that want to figure out how to move funds between chains in a provably optimal way. And it's coordinating that with the underlying settlement. So this is chains, this is transport protocols like Layer 0, Hyperlane, whoever has minting rights of a token. And it's, of course, also canonical bridges. We have been working on this problem. By we, I mean collectively crypto. I started working in this space back in 2016. Back in 2016, some of the biggest problems that we were trying to solve were scalability, gas abstraction, account abstraction, interoperability. We have been working on these problems for like almost a decade. It's kind of crazy, right? It takes a really, really long time. But we're actually close. And I think that this is something that people don't really appreciate enough. Rollups and the rollup thesis is the correct thesis. It's working, right? We have figured out how to horizontally scale this space to an infinite amount of block space. And we have also, at a high level at least, figured out how to do interoperability. What we need to do is just solve this final like user experience piece, right? I always joke about this, but like I really want to get to the point where like this problem is solved. And to an extent where like I don't even necessarily think it matters who solves it. Because I want to go and build more interesting stuff on blockchains. And I'm sure everybody else here does too, right? Like I would love to build like a actually fully on-chain decentralized video game. I would love to build a fully on-chain decentralized AI like machine learning model, right? I would love to build on-chain decentralized Wikipedia. But we can't because right now the experience isn't there. But we're close. And I think that from our perspective, this is the missing piece. We think that if you can really solve these like underlying liquidity challenges, and you can bring down the cost of actually getting capital to places by an order of magnitude, you can allow for anybody to run a solver, right? You can make that power law graph into a straight line where anyone, regardless of whether you're running it at home with a dApp node or you're running it on like an AWS instance or whatever, anyone can actually go and help facilitate these transactions for the 1,000th chain, for the 10,000th application-specific rollup. That's where we want to get to, and that's what we think, that's kind of the core of the Everclear thesis. I think I have time for questions. Any questions? They don't even have to be about Everclear. I just want you to talk to me. Yeah. Yes. Yeah. So the question was, I talked about the Dutch auction. I did kind of like gloss over this. It's hard to find the right balance between like technical versus non-technical when you don't really know exactly who's going to be in the audience. So like I was like, Dutch auction, hand waving. Oh, I can't go back. Interesting. Okay. Anyway, the question was, is the Dutch auction like verifiable? Is it decentralized? So basically, the way that our system works is it's its own rollup. this rollup is computing the optimal outputs for every participant, right? It's a neutral system, and the reason that you need it to be a rollup is that you want the outputs to be verifiable. So if you're, say that we are competing solvers or competing market makers, we don't trust each other. We have an incentive to coordinate because it gives us better outcomes from a liquidity perspective, but I don't trust you, and you probably don't trust me. And that's actually exactly what blockchains are designed to solve. And so this system is its own rollup. The Dutch auction runs as a smart contract on top of the rollup. It's, as I mentioned, it's like a V0 mechanism to do netting and to do pricing within the system. But the system itself is also very open and modular. So like once we kind of head into our V1 and beyond, what we want to do is open it up such that people can come and build their own strategies that actually may be more hyper-tailored to like a specific asset or specific ecosystem. I didn't really touch on this, but this problem is actually a lot even more complex than you can imagine. So think about USDC, for instance, right? Today's USDC backbone is super fragmented. You can use certain liquidity bridges to get USDC from some chains to other chains, but you can use CCTP to get to other chains. And so if you have a transaction that's going from Gnosis to Arbitrum, Arbitrum supports CCTP, Gnosis doesn't. How do you reconcile that? How do you actually make it work? And right now, the answer is you can't use CCTP. But with Everclear, the answer can be more interesting, right? You can write a settlement strategy on Everclear that allows for netting off a Gnosis to Phantom transaction against an Optimism to Arbitrum transaction, so you still get the CCTP benefit. Yeah, so one of the...
Could you repeat the question in the mic?
Am I worried about MEV and intent ordering? Yes.
Thank you.
So there's a few different ways in which MEV kind of plays into this, and it's something that we're trying to think about a lot. So there's different ways in which MEV can creep into the ecosystem, but one of the things that one of the guarantees we want to give to solvers is that everything is ordered. So any transaction, or basically any deposit that gets put into the system by a solver or market maker, is issued that solver is issued an invoice, which represents an IOU from the protocol back to the solver on whatever chain. Those invoices are ordered in a FIFO queue. And so, in effect, one of the things that we're trying to guarantee with the rollup is that ordering is preserved. If the rollup sequencer or if someone else changes the ordering of that, you can actually go and dispute the rollup sequencer just through the normal Arbitrum fraud proof process. Now, there's also other forms of MEV here, for example, how do you order the transaction? How do you order the messages of the deposits going in? We're looking at some encryption stuff for that. That's pretty interesting. But yeah, I can talk to you afterwards about some of that if you're interested.
Then we have time for one more question. Can't see anything.
Oh, several questions.
There. What's the readiness state
when
of it?
mainnet, yeah. So the code is actually, we're actually deleting a bunch of code right now because we are sort of deprioritizing some of the existing bridge-related stuff we're doing just because what we're seeing in the market and what we're seeing with partners. And so I think the deletion is going to finish, I think, in a week or so, and at that point, the code is going to be complete. After that, we are sending things off into security reviews and audits. That process is always a little bit of an open question, but we're kind of targeting a couple of months ish for getting all of those reviews done. We want to make sure that this is super, super solid. Of course, the target market is people that are going to be sending transactions with size. So, we have to be careful. I always hesitate to give timelines, it's going to be in Q3 though, for sure.
All right. Then, Arjun, I said last question, but I actually have a really last question here, promise?
Excited to hear it.
Yes, thank you very much for the interesting presentation. I have one question, because your model is based on netting.
Yes.
What is the future of bridges, like burning and cross-bridging and so on? Well, because the coins from your systems are not leaving the ecosystem, they're staying in their own system.
Yes.
So what is the role of bridges in its future? Thank you.
So, I wish I could go back. I can't go back, unfortunately, to the last diagram. There's a really great layered diagram here that I hope that you got a chance to see before I changed it. Oh, amazing. Thank you so much. So what we're kind of seeing is happening with bridges is all bridges are becoming one of these, basically. They're either becoming an order flow auction. So things like Uniswap X, for instance, is they want to prioritize their own order book mechanism. Socket and LeFi are effectively already order flow auctions. or they're becoming like solver protocols or something like that, right? Like everybody's sort of like specializing, and this is a sign of ecosystem maturity, where people are realizing, okay, bridging is actually this not one problem; it's a collective of problems, and we can all specialize on some aspect of this and win on that. I think the role of bridges in this, with Everclear, like Everclear's target market is effectively bridges, right? When we say we're targeting solvers, what we mean is the LPs of bridges that are actually functionally operating them. Today, that is the bridge protocols themselves, but once these things are decentralized, it can be an open ecosystem. And so, like, bridges will still exist, and they should, right? We can't, like, there's so much specificity that comes with bridging, like bridging into certain ecosystems, assets, and then there's going to be a lot more that happens with like chain abstraction, like, you know, being able to have like protocols, like for example, Relay, that allows you to go and purchase an NFT across chains, right? That's a specialized use case. It's an important use case, but like there's so many of those kinds of use cases, and there's not going to be like one single generalized protocol that serves all of them.
All right, then we have just enough time to give you a round of applause.
Thanks, everybody.